In this video, I am going to provide an introduction to the concept of torque in physics. Now, the easiest way to understand torque is by imagining a door. So let's say that this is the hinge of a door, and let's say this is the door itself. Now, imagine that you apply a force right here, let's call it F. So you're pushing this door open, and the door is going to rotate open, and it will rotate around this axis of rotation, which is the hinge of the door. Now, let's call this distance between the axis of rotation and the point where you actually apply the force, let's call that L. In order to calculate the torque in this situation, what we have to do is we have to draw an imaginary line that extends from the force, and this is called the line of action. Now, to calculate torque, we need to know something known as the lever arm. Now, the lever arm is the perpendicular distance between the axis of rotation and the line of action. So in this case, the lever arm is going to be this distance right here. Let's call that R. So the perpendicular distance between the axis of rotation and the line of action. Now what we'll notice is that in this case, since our force that we're applying is parallel to the axis of rotation, this distance L and this distance R are actually the same. Now in order to calculate torque, here's what we can do. Just take the force and multiply it by the lever arm. So that's it. That's all you have to do to calculate the torque in this scenario. But now imagine a scenario where you actually apply this force at an angle. So again, let's say we have a door. We're applying a force to push this door open. But now imagine that this force is being applied at an angle right here. And this acute angle between the door and the force, let's call that theta. So this distance, this is still L, the distance between the axis of rotation and where the force is applied. But how do we calculate R, the lever arm? Well, remember, the lever arm is the perpendicular distance between the axis of rotation and the line of action. So in this case, when we have this force applied at an angle, the line of action, if we extend that from the force, this is the new line of action. And the lever arm is then going to be this distance right here that is perpendicular, so it forms a 90-degree angle with the line of action. So this is our lever arm. So how can we actually calculate this value of the lever arm when the force is applied at an angle? Well, notice what we have here. We can draw a right triangle. And let's go ahead and pop that out here and draw it right here. So here's our right triangle. This is our 90-degree angle. This is R, the lever arm. The hypotenuse of the triangle is L. And this angle right here is theta. And by the way, the reason this is theta is because if you imagine we have the door here, here's the force that's being applied. If this angle is theta, then this angle must also be equal to theta, since these are vertical angles. Now, how can we solve for R in this particular scenario? Well, if you recall from trigonometry, the acronym SOHCAHTOA, the sine of an angle must be equal to the opposite side of the triangle divided by the hypotenuse. So what we can say is that the sine of this angle theta, it must be equal to the opposite side, that's R, divided by the hypotenuse. In this triangle, the hypotenuse is L. Now notice to solve for R, we can just multiply both sides by L. So what we end up with is R is equal to L times the sine of theta. So in this scenario, torque, it's still calculated as F times R, but we just saw that R can be found by doing L times the sine of theta. So what we can say is that the torque is equal to the force times L times the sine of theta. So this is a super useful formula to know when you have a force applied at an angle, because to calculate the torque, you only need to know the force, the angle, the acute angle that it was applied at, and L, this distance between the axis of rotation and where the force was applied. So these are the two equations that you can use to calculate torque. If the force is being applied at a perpendicular angle, then the equation is pretty simple. And if the force is applied at a different angle, then it's just a little bit more work where we take the force, we multiply it by L, the distance between the axis of rotation and where the force was applied, and then we multiply that by the sine of the acute angle between the force and the door. So with that in mind, let's check out a couple examples of how to actually calculate torque. Alright, so let's check out these two examples. Let's consider this first example. Let's say we apply a force of 100 newtons on this door, and we're applying it 2 meters away from the axis of rotation. In this scenario, the force that we're applying is perpendicular to the axis of rotation. So to calculate the torque, all we have to do is take the force and multiply it by r, the lever arm. So in this case, the lever arm is this perpendicular distance right here, which is 2 meters. So all we get is 100 newtons times 2 meters, and that comes out to 200. And our units will be Newton meters. So that is the value for torque. Now let's check out this second example. We're applying a force of 250 newtons, and this acute angle between the force and the door is 60 degrees, and we're applying it 0.28 meters away from the axis of rotation. So in this case, since we're applying the force at an angle, we'll need to use this second formula that we derived. So we'll say the torque is going to be equal to the force, which is 250, times L, the distance between the axis of rotation and the point where the force was applied, so that's 0.28, times the sine of the acute angle, which is 60 degrees. So if you punch this into a calculator, this comes out to about 60.62. And again, we'll say Newton meters. So that is the torque that's being applied in this particular situation. So that was just a quick introduction to the concept of torque, along with a couple examples of how to calculate torque.